Hi all, today we are going to learn about limiting reactant. Have you taken your breakfast? If haven't, let's make some sandwich as our breakfast. For making a sandwich, we need to prepare 2 slices of bread and 1 slice of cheese. If there are 5 slices of bread and 2 slices of cheese, then how many sandwich can we make? The answer is 2. 2 sandwich are the products. The leftover 1 slice of bread is the excess reactant. And the limiting reactant is the cheese. Do you get it? Let's continue to define what is limiting reactant. Limiting reactant is completely consumed in a reaction and limit the amount of product formed, while excess reactant is not completely consumed in a reaction and remain at the end of the reaction. So let's look one more example. Based on this diagram, 4 t-shirts match with 7 trousers. So we can make 4 outfits. So the limiting reactant is the t-shirt and the excess reactant is the trousers. Now we go for the real chemistry question to decide the limiting and excess reactant. Based on this question, we need to find the limiting reactant and mass of excess reactant remain when 1.5 gram of calcium carbonate react with 0.73 gram of hydrochloric acid. So first of all, we need to write a balance equation. For this question, we can write the balance equation by using inspection method. So 1 mole of calcium carbonate react with 2 mole of hydrochloric acid, then produce 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of water. Next, we need to calculate the given mole of each reactant in the reaction. According to the question, 1.5 gram of calcium carbonate is given, so we divide 1.5 gram with the molar mass of calcium carbonate, which is 100.1 gram per mole, so we get 0.011499 mole. Same for here, we need to calculate for the mole of HCl. Given 0.73 gram, divide by the 36.5, the molar mass of the hydrochloric acid, so 0.02 mole of hydrochloric acid. These are the mole given by the question. Always remember, we need to give the answer in 4 significant value if the answer not the final answer yet. Next, we need to use the balance equation to determine the mole ratio of reactant used. So check again the balance equation. 1 mole of calcium carbonate react with 2 mole of HCl. Okay. Next, we need to compare given mole of reactant to mole ratio of balance equation. Okay, so this is based on the balance equation, and then given is 0.011499 mole of calcium carbonate. So now we need to solve this equation by stoichiometry. Okay, 0.011499 mole times 2 divided by 1, cancel off, so remain 0.02998 mole of hydrochloric acid. From here, you must understand, given is 0.02 mole of hydrochloric acid, but needed is 0.02998 mole of hydrochloric acid. So it's not enough if we are using this number of mole of calcium carbonate. Okay, we need this amount of hydrochloric acid. So from here we know that HCl is the limiting reactant. Next, since we know calcium carbonate is the excess reactant, so we need to find out the mass of the excess reactant. Again, we need to compare, okay, calcium carbonate with the hydrochloric acid. We always must compare with the limiting reactant. So 2 mole of hydrochloric acid equivalent to 1 mole of calcium carbonate. So based on the question, 0.02 mole of hydrochloric acid is given. So we need how many mole of calcium carbonate? 0.01 mole. So check again. Based on here, the mole given by the calcium carbonate is 0.01499. And then we just need 0.01 mole of calcium carbonate if reacted with 0.02 mole of hydrochloric acid. So, okay, we can form this equation. So substitute the value and then find out the mass or the mole of calcium carbonate remain. Since the question asks about the mass, right? So we need to times the mass of calcium carbonate and we get the answer. So the excess calcium carbonate is 0.499 gram. Okay. So can you digest? Don't be worried. Let's do some summary. Okay. Step 1, we need to write the balance equation. Step 2, we need to calculate the given mole of each reactant in the reaction. Okay, step number 3, we need to use the balance equation to determine the mole ratio of reactant used. Okay, step 3 is very important. Actually, here is the part to determine the limiting reactant. And then step 4, we need to compare given mole of reactant to mole ratio of balance equation. So here always remember we must compare with the number of mole of limiting reactant. And then the last step, step 5, we have to answer the question accordingly. Check whether the question asks want us to find out the excess reactant or find out the mass of product form and so on. So now try to solve the limiting reactant question that related with the reaction between aluminium and iron oxide. So based on here, right, okay, you are very lucky because step 1 is given. Even though the equation is given, make sure that you check whether balanced or not. So we check 2 aluminium, 3 oxygen, and then 2 iron, 2 iron. Yes, this equation is balanced. Okay, step 2. What are you going to do? We need to find out the mole of aluminium and mole of iron oxide. Okay, so check. So this is step 2. So this is the mole of aluminium given. This one is the mole of iron oxide given. Okay, step 3, what are we going to do? We have to use the balance equation to determine the mole ratio of reactant used. So compare. Based on the equation, 2 mole aluminium oxide equivalent to 1 mole of iron oxide. So based on here is 4.5926 mole of aluminium. So stoichiometry, you get the answer 2.2963 mole of iron oxide needed. Hey, given is 3.7 something, needed just 2.29. Is it enough? Yes, enough. So try to make this statement. Since mole of iron oxide given is 3.7 blah blah is more than iron oxide needed, which is 2.29 blah blah. So iron oxide is the excess reactant. Thus, aluminium is the limiting reactant. Since the question wants us to find out what? The mass of aluminium oxide form. So we need to compare, okay, the limiting reactant 2 mole of aluminium with 1 mole of aluminium oxide and then check how many mole of aluminium oxide is needed. The answer is 2.2963. Then we times the molar mass of iron oxide and then we get the answer 234.22 gram. So is it the step same with the previous question? Same, right? Okay, now we try to answer the question number 2. How much of the excess reagent is left at the end of reaction? So now we need to compare aluminium with iron oxide. Okay, so we compare based on the equation given. Okay, 2 mole aluminium oxide is equal to 1 mole iron oxide. So again, using the mole of aluminium given by the question, we solve the problem by stoichiometry. So we get the answer 2.2963 mole iron oxide is reacted. So the number of mole of iron oxide remain reacted. We try to use the given minus the reacted one. We get the answer 1.467 mole. Since the question 1 molar mass, right? So we need to time the molar mass for iron oxide. So the mass of iron oxide remain at the end of the reaction is 234.06 gram. So this is the final answer. So make sure that the final answer must in 2 decimal places. Okay, 234.06 gram. 0.6 gram. Okay. Now we continue with the advanced level. So try to solve this limiting reactant question to test your understanding. Okay, if you have any question, please don't hesitate to consult your lecturer. Good luck. Thank you.